simplify the limit as x tends to 3 of, yikes, x squared minus 7 over x cubed minus 10x squared plus 33x minus 36. Okay, so most of the time when I see a limit, my first instinct is maybe I can just plug in. I mean, the top's a polynomial, the bottom's a polynomial. Those are both very well-behaved functions. Limits work really well with them, so we can try. Now, I'm not expecting anything fantastic, but on top we get 9 minus 7, so the top goes to 2. On the bottom we'll have 27 minus 90. I'm going to have to keep track of this. 27 minus 90 plus 33 times 3, so that's plus 99. Okay, I can cancel those out and just leave me with a 9. Minus 36, 27 plus 9 minus 30. Oh, that's 0. So when we do the sort of standard, what we call naively plug in, hoping that sort of everything's continuous and it'll work out, we can just evaluate with limit laws and stuff like that, we find that we have 2 over 0. Written sort of slantily here, but that's because the polynomial on the bottom is so big. But we have what I like to call an infinite form. We have something that isn't 0, in this case 2, divided by 0. Now, does that mean we're stuck? No. What this typically means is we should expect an infinity, a minus infinity, or the limit to simply not exist. Those are sort of the 3 options that you can run into here with a something over 0, as long as the something, of course, is not 0. If it was 0, you'd have an indeterminate form, and that could be any number of techniques. But when we look at this, okay, 2 over 0, the top is going to a nice, well-behaved 2, but how exactly is the bottom going to 0? That's what we have to figure out, because that's going to tell us, does this properly settle down? Now, it's a 2-sided limit. So it might be that from one side we go to infinity, one side we go to minus infinity, and so combining them for the 2-sided limit, we'd have a DNE sort of situation. The limit does not exist. But we'd have to sort of sort that out. With polynomials here, the best thing to do is probably factor out 3. So that's the first thing I'm going to do. We'll split into the 2 one-sided limits if we have to. But we got x squared minus 7, which really we don't need to worry about that. And then what was it? It was x cubed. It was minus 90, so it was minus 10x squared plus 33x minus 36. So we're going to factor out. There's at least one factor of x minus 3 in here, otherwise it wouldn't be able to go to 0. That's basic polynomial sort of theory. So let's see if we can factor out an x minus 3. Now it's a cubic, so you might have to spend a little bit of time. You might have to break out something like the polynomial long division, which is perfectly fine. Let's see. In order to get x cubed at the front, it has to be x times a single x squared. If you had a 2x squared, you'd have 2x cubed when you multiply it all out. Similarly, in order to get a minus 36, the only way you get the constant term in a product is just by multiplying the constant term. So this has to be plus 12. And so we could probably figure out what's going to be in the middle just by saying, oh, well, the next thing has to be 33x. Well, where's that 33x coming from? It's 12 times x minus 3 times some other thing times x, so minus 3ax. That has to be 33x. So get rid of the x's. 12 minus 3a has to be 33. So minus 3a has to be 33 minus 12, so that's 21. So a has to be negative 7. Right? So we can just come over here, grab our little eraser, and say, okay, so this should be minus 7x in the middle. And if we're worried, we can double check. Okay, minus 3 times x squared is minus 3x squared, and then x times minus 7x gives me minus 7x squared. So yeah, that's the minus 10x squared there. Okay, so the bottom we have this x minus 3 factor that we can deal with. Okay? Now, if you check, plugging in, you should always do this because sometimes there are multiple copies. Sometimes you get lucky and there's only the one. But if you check, plugging in 3 again, 3 squared minus 7 times 3 plus 12, you get 9 minus 21 plus 12. This is 0 again. That means there's another factor. You can sort of factor as you go. Like you can factor this out once, try the question again, factor it out again. It's probably a good habit, especially if it's a bigger polynomial, to say maybe there's a few copies of x minus 3 in here. In fact, there are. So we already have one copy of x minus 3, but we can bring out a second one, and then we can factor this as, so you'll get an x, and then to get plus 12, you'll have to have minus 4. Okay? So the bottom can factor as this, and this definitely doesn't have any x minus 3 factors. So looking at it again, writing up our limit. So I can write the bottom. So the top, you could factor that with some root 7s. We don't really care what's going on with the top. We know it's heading to 2. But the bottom is going to x minus 3 squared times x minus 4. So now if we analyze the signs, what's happening? On the top is going to 2. A nice, healthy, positive number. We don't care about the 2 so much as the fact that it's positive. On the bottom, we know that this bit's going to 0. We'll deal with it in a moment, because that is important. We have to analyze that sign. But as you plug in 3 in for x, this part tends to minus 1. Which, again, we don't so much care about the minus 1 of it all. We care that this factor here is negative. So we have a positive divided by a negative divided by, well, is x minus 3 squared? Is that going to be tending to... I know it goes to 0, but is it going to 0 on the positive side? On the negative side? Can I not tell, and I have to break into left-handed or right-handed, or left-sided or right-sided limits? And if it was something like just an x minus 3 or an x minus 3 cubed, we would have to actually break this up, and you would probably get a DNE ultimately. But x minus 3 is going to 0. I don't care what small values this is. If you square something, it's positive. So x minus 3 squared, x minus 3 to the 4, x minus 3 to the 16. As x tends to 3, we'll go to 0 on the positive side. So really, analyzing the signs here, we have a positive divided by a positive times a negative. So overall, the expression is guaranteed to be negative as your x values are heading to 3, which means that the limit here will be a minus infinity. Okay? It's minus infinity because overall these values are negative. And since the bottom is going to 0, the whole thing's getting really big because the top's not going to 0. So it's a big negative, which we symbolize with minus infinity. And there we go.